Hello, everyone, and welcome to our webinar on Predictive Analytics powered by SAP HANA. My name is Amanda Whirling, and I'm the Director of Marketing for Decision First Technologies, and I will be your moderator for today. For those of you who don't know who Decision First is, we are an SAP Gold Channel Partner and 7-time Business Objects Partner of the Year. We provide certified training and consulting services for SAP Business Objects, Enterprise Information Management, and HANA solutions. We have been working with the Business Objects technology for over 15 years, way before the SAP acquisition. So we have a deep understanding of what it takes to be successful and to maximize your business objects investment. With that brief intro of Decision First, let's get started with today's call. Due to the large number of participants, I have muted all phones for the duration of the call. However, you will be able to ask questions via the chat feature of WebEx. Just make sure you're sending your question to both the host and the presenter. At the end of the presentation, I will ask the speakers as many of the questions as possible given the time frame that we have. If we do not answer all the questions and we have your complete registration information, we will provide answers to you after the call. Today we have two excellent guest speakers. First up will be Mike Watzke, Senior Director of Business Intelligence for the Global Center of Excellence for Analytics at SAP. Mike will take us through the presentation portion of the webinar, and then Hillary Bliss, Analytics Practice Lead for Decision First Technologies, will lead us through the demo portion of the webinar. So Mike, I'll go ahead and turn it over to you.
Thank you, Amanda, and just want to say a special thank you to the whole Decision First team for the incredible work that you've done in the past few weeks as we've planned this event, and kudos to your team for being prepared and for the amazing work that you're doing and being a leader and paving the way for a lot of other partners to see how it's really done well, and I think that the customers today on this webinar are going to appreciate that. So, as Amanda said, my name is Mike Watzke. I'm in the Global Center of Excellence for Predictive Analytics here at SAP. What we're going to do is just start out with some slides that really give you a good idea of what most of our customers are doing and where I think most customers would like to be. Many times we talk to customers and they think that they're doing it, or they think that there's certain individuals in the organization who are doing predictive analytics, and sometimes they think that that's simply because they have financial planning and budgeting and someone's doing forecasting, or they're aware of a data scientist. I like to joke that the data scientist sits in the corner somewhere, and sometimes people don't even know who or where that person is or what kind of stuff they're doing because everybody's afraid of them, right? It's all PhD stuff. And sometimes that's the case, and many times it's not. And sometimes it's just an awareness thing. So what I want to talk to you about to start out today's conversation is really just getting to that place to where you can really be doing advanced analytics. Davenport, Gartner, there's been a lot of studies, Forrester is another good example, that have come out just validating the very necessity of doing predictive analytics. Most people are doing the what's happened. We all know that that's very traditional, formatted, standard, operational kind of reporting. Most organizations are also doing the why did it happen, which allows us to drill down. We do a little bit of data discovery. Hopefully we're doing that with the SAP BI portfolio, but I know there's other tools in the market for doing that kind of thing. And then there's this capability to really get into the predictive modeling. So what will happen? And lastly, what's the best that could happen? That's really getting into expectant time frames and understanding the forward-looking analysis that a lot of organizations have a very difficult time doing on their own. And we have a platform that allows you to answer all of these now. Not only that, we have this platform that allows us to really close the loop, and I'll talk about that more. One of the biggest sources of information that we see happens to be customer-oriented, right? So in retail and consumer packaged goods, you could say customer or constituent for public sector. Most people in every industry deal with people, deal with some sort of customer, whether that's a wholesale customer, an end user, consumer, or a constituent. And you can see that that's the biggest trend here that we're seeing in terms of sources that can be tapped for predictive analytics. These others really are somewhat related: sales, marketing, product, and financial. And the great thing about this is that they're all directly related to revenue. They all directly increase revenue, optimize budgets, allow you to realize a better bottom line. You can also extend your analytics capabilities by moving up the curve, going more from just generic predictive analytics, so why did it happen, what will happen, but really getting into this area of optimization. And I mentioned a minute ago this concept of closing the loop, and I'll kind of bring that back home here in just a minute. But the neat thing about optimization is that you have not just resources that can conduct predictive analytics, but you have a good idea of what you want to do with the results of it, right? And that's really the key here. And that's the key for anything in terms of analytics. If you have a BI tool and at the end of the day, your job is to get a number out of the system, if you keep that number to yourself, it does the organization no good. If your job is to run predictive analytics and to get a number, to get reports out to people, to make them more proactive instead of reactive, to give them that forward-looking insight that they really need to be successful and to gain a greater competitive advantage, if you keep that data to yourself and those reports to yourself, that does the organization no good. So the real value proposition here is not just having a very intuitive tool to be able to conduct predictive analytics that looks a lot like and acts like and integrates with your other SAP investments. It's the fact that you can actually close the loop and do something about it. Okay? We call that predicting and acting, insight to action. And that allows you to, again, have greater competitive advantage and realize that greater analytics maturity model. So why SAP? There's other vendors that are doing this. There's other vendors that have been around for a lot longer in terms of predictive analytics. We have seen this as a natural extension of the business objects portfolio here at SAP. There's realized and very powerful synergies, not just with the business objects family of products, but with SAP ERP, with BW, from a data mart perspective, Sybase IQ, and real obvious, and one of the reasons we're having this conversation today and what you're going to see in the demonstration is an enormous value proposition for HANA. So those customers that are looking at, or you've already invested in HANA, you have a place for big data, high performance, can run analytics inside of memory now, and it makes a great use case to use HANA for predictive analytics, because not many people want to do predictive analytics with small data sets. Usually they're large data sets, they're volumes of historical information. So a perfect marriage of really all three of these components together, if you can see it that way. And we'll validate that more here today. So again, why SAP? We weren't even on this Forrester chart last year. So we've come a long way in a very short period of time. We're very excited about that, and the fact that we're in the leaders quadrant along with IBM and SAS. And again, those are kind of the vendors that have been in the market for a very long time and have a lot of the market, and rightly so, because they've been around for a very long time, and they've been developing and coming out with new releases of those products. We've joined those tools and feel that we've got some additional value propositions that those vendors do not have, and we'll talk about some of those today. But the fact that we have such a tight integration with HANA, we can run in memory, in database, predictive analytics, and use predictive analysis as a tool that's very intuitive and very approachable from a business user perspective, really for the modeling side of things, is very unique to us, and you're going to see that today. You're also going to see in the demonstration that we designed a tool that's not just for data scientists. It's powerful enough for them, but it's something that was designed for business users as well, such as analysts. And I think you'll agree once you see it today. And some of the reasons will be just the UI, the experience of going through building a model, but also the very fact that we're hiding coding from people, where I think that we're going to even move up that leader quadrant a little bit more toward those two other vendors is is like shortly right after Sapphire time frame, so we're excited about that. Okay, I'll advance to the next one, the 3 types of users. Okay, so one of the neat things that we've done, and you'll see in the demonstration data that we have a preset series of algorithms, functions, statistical functions, if you will, available in the tool. You're going to see what they are, and you'll notice that we have a number of preset algorithms. And one of the things that we did before we went generally available with a product is we surveyed the market and surveyed a lot of our customers and found out that the ones that we packaged in the tool today meet or exceed 90% of the use cases that customers want to use predictive analytics for. So it's not a very overwhelming approach. There's not hundreds and hundreds of algorithms, and we know that there's some of those available in other tools, and we think that tends to be overwhelming based on what we're hearing from our customer base and from what the market is using today. The other thing that we did is we looked at our representative user base. Who's using our analytic install base? And we found that 0.001% of our install base across our millions of users happen to be data scientists. Now, that doesn't mean just because of the smaller number here that we don't care about them. We absolutely do. And we designed the tool to where they can do certain functions within the tool in a collaborative, multi-developer type of approach. And we'll talk more about that. And that means that they can do more of the complex predictive models, create simulations, create parallel or serial type of models in a subsequent release, and do all that kind of stuff that they expect to do. Run through tests and different versions of those algorithms, and then publish the results and share that document with the people that make up more of the 3% of our audience today. And those are really the data analysts. Their job is to transform and enrich data sources. They create more of the simple predictive models and simulations. They visualize the results. They create all the sexy charts and make sure that they're published out to the larger audience. Now, what we find when we talk to customers, and what we found in our initial surveys, is that the 97% of the people that really need to see the predictive analytics do not get it. So there's a broken process here. And when we talk about closing the loop, we talk about bringing data into the system, modeling data, collaborating on that between analysts and data scientists alike, publishing the results, and the results have to go to the masses, to the 97% that need it. Everybody needs predictive analytics. Nobody just needs historical data. That's traditional BI. Everybody needs predictive because it does something for everybody in any job capacity. So if you're a traditional BI user and you're not used to, or your customers aren't used to getting predictive analytics, we need to change that. And we can give you a lot of different use cases for why that is and what it's going to do to transform their business, their day in the life of their job that they have to get done. Okay, if you can advance to the next one for me. Okay, so this slide, this talks about kind of the typical situation that we see, and I'll go over the next few slides rather quickly. I want to make sure that Hillary has plenty of time to show you some good stuff today. But we talk about the different data sources and types. Everybody has this problem. I don't know I've never gone into a customer and they said, yeah, we have one authoritative source, right? That was the 90s thing, wasn't it? Where everybody said, oh yeah, dump everything into a data warehouse and run it on Teradata or Oracle or Sybase, and it can be your single authoritative source for everything. I think it's impossible. There's just too many. There's too many things going on in the social world these days with social analytics and Hadoop and Hive, and you've got different distributed databases. You make acquisitions and bring other companies into the fold. You have partners. You have this large ecosystem of suppliers. It's almost impossible to do that. So you need to have a tool that allows you to bring data in regardless of where it sits. So I want you to know, too, that in saying that, nothing else is required from SAP to actually run predictive analysis as a tool. You'll see that today. Again, there's a perfect marriage and a great use case for doing it with HANA. So we do predictive on top of big data is very powerful, right? But know that we can do that and bring other data sources into it. And I imagine Hillary will say a few things about that too when she shows you the demonstration and how we can use data services. We can bring things into HANA. We can also bring feeds of data directly into the predictive analysis tool itself. And you'll see the difference between the two today. When we have these conversations with customers, we always find that there's non-meaningful data. There's a lack of integration. There's a big data issue, and they don't know how to solve it. We also find that there's a few number of users, and I mentioned that earlier. For most customers I talk to, there's anywhere between 1 and 6 data scientists depending on the size. And the average, if you say the range is between a 1 and 6, I'd say the average is probably a 2. And the reason for that is because it goes downhill as well. There's a lot of companies that they don't have any data scientists, right? The data scientist is someone who is a data analyst who is attempting to do as much as they can inside of Excel or another tool, or sometimes with a calculator. So for that type of individual who usually absolutely knows what they're talking about, they usually have a deep statistics background, they've used other tools in the past, some of them have PhDs, it's a very specialized skill. Right? There's usually a lack of awareness between what the business community and the data analyst is attempting to achieve and what the data scientist has achieved. They're usually given instructions and they're handed it off to it and say, please do this. It comes back. It's a very iterative approach, kind of going back and forth. It's very high total cost of ownership because you can't realize an SAP investment. You have to go out and buy another tool for doing that for that kind of specialized skill. And then lastly, we have this problem with broken processes, right? So there's a lot of manual efforts that go into to creating predictive analytics today. There's a lack of understanding, again, not just of awareness, but of understanding of what the results are telling them that comes from someone like a data scientist. And it's usually not aligned to BI and reporting at all. It's separate. And we have a tool now that can really align that together. So Amanda, if you'll go to the next one for me. So this vicious cycle that we see inside of that process is a problem, and it's a problem in most organizations. I won't say every. We do speak to customers where the data scientists and the business community are in like a competency center. They're very much involved. They're very much attached. They have the same projects, the same goals in mind, right? And they collaborate. But I would say 95 to 99% of the companies we work with, that's simply not the case. And this is somewhat of a humorous kind of slide, but you'll notice that again, the data scientist who's presenting is trying to present the results to an executive, and that person has a question mark over their head, right? So we see that a lot. And then the vicious cycle kind of comes in because usually what the data scientist is trying to get across or relay the results, here's what I found, here's the R-squared means of the statistical calculation. Here's what the regression analysis is telling us. Usually the business audience isn't quite sure what's trying to be conveyed, and or they have other needs that aren't being met through that report. So it's many times goes around and around and around, and sometimes it never ends, and people get frustrated. So if you'll go to the next slide for me, Amanda. As I started this conversation, I talked about closing the loop. The SAP difference is that you have the ability to bring the data in, regardless of where the data sits. You have this ability to make it integrated and conformed and meaningful with semantics and with enrichment. You have this ability to provide a fast, real-time performance for big data experience, right? And that's all back-end stuff, right? That's all great. But we still have this notion and this value proposition, if you will, of ensuring that we remedy a difference, a uniqueness that sometimes isn't found in the market today with your SAP investment or what you're looking at investing from SAP. So secondly, we can get into the prediction. So we can do predictive capabilities and results for the masses, which means that we're opening up the gate a little bit. When you see the tool today, I think you'll agree with me. Some of you may have seen it already. You'll notice that it's drag and drop, it's point and click, it's very intuitive. You can't blow it up. You're passing parameters to functions and algorithms and not having to worry about calculations that go on and statistical formulas because they're too complex. You have a lower total cost of ownership with your business objects and HANA integration. And then lastly, we can close this loop. So we can handle problem notification, data exploration and visualization, predictive modeling very intuitively, and we can pass the predictive and proactive results to the business users who really need it in their day in the life job. And it's aligned and it's integrated with traditional BI reporting. That's what we mean by closing the loop. If we leave out one of these, where we stop at just giving you predictive capabilities and we don't really have a way of publishing out, especially through business objects, back to HANA, where things like Webby and Design Studio, some of the newer stuff, mobile analytics can all consume that content now, and it's kind of a perfect world. It's just like we're doing things with BI today. Okay, if you'll go forward, please. So what is SAP Predictive Analysis? So Predictive Analytics is kind of casts a wider net across some things that are going on here, including HANA, including predictive analysis, and including predictive capabilities exposed through things like visual intelligence, you know, when you're using time series type of and forecasting analysis, through and embedded inside of a HANA application, inside of an SAP ERP application, you might have predictive capabilities in a CRM application, for example, and a lot of those come from something like this. So what is predictive analysis? Predictive analysis is a tool. This is a workstation tool. You'll install it right on your workstation. And you'll notice in the left-hand screen, it's an identical experience with visual intelligence. Why is that? Because the visual intelligence code line was completely brought into predictive analysis. So if you have licensed predictive analysis, you're licensing a superset tool that includes the visual intelligence code line, and that's good. That means that all that data discovery, data manipulation, creating joins from multiple sources, doing some enrichment semantically, creating measures, creating derived measures, making changes to attributes, all that's done in the first part of that experience. Anybody can do it, right? And then the second experience of it is just another tab in here, and it's called Predict, and you go in there, and that's where you create your models, and you're going to see that today. Next screen, if you would, please. So predictive analytics, again, is the best use case for predictive analysis to be used as a tool. Again, it's not against CSV, Excel, and small departmental data sources like that, right? There's a good use case for doing it if you have an authoritative source, you have a data warehouse that uses you know, Sybase ASC or Oracle or Microsoft SQL Server, absolutely. But the really neat value proposition that we have with HANA is that not only do we have an immediate direct connection to HANA within predictive analysis as an online source, but it also means that we can do in-database processing. So when we realize and connect to HANA and we see our schema in there and we see our analytic views and we can do predictive analytics on it as a source, we're really just bringing a sample subset of data over from HANA, because if it's millions and millions of rows of data, that's your big data set. We wouldn't want to bring it over to the workstation anyway. We wouldn't want to replicate it, for one thing, and it would take up a lot of memory. Secondly, we're able to pass the processing off to HANA, where it should run, and it'll run in memory, right? So that data is already in memory. If we have this ability to take a sample subset over, create a model over in predictive analysis, because you can't create the model inside of HANA. You can use a function inside of HANA, but you can't create a model that has a chain series or a parallel series of events going on. But we can do that in predictive analysis. When you click the Go button, it actually pushes Create SQL and pushes the logic over into HANA, and that's where it runs, and that's where it should run. That's why we talk about it as being a perfect marriage. Again, it uses in-database predictive algorithms that are built into HANA. If you're a lot of you on the webinar are technical, so we do that through something called PAL. That's the predictive analysis library that's built into HANA that comes with it. In PAL, there's in-database native algorithms. There's also an integration with R that's usually installed on the same server, and those are the algorithms that we actually use inside of the application. There's also a custom wrapper available, so you can include any of the, I guess there are up to 4,000 algorithms now through the R open source community. You can write your own, so you can go above and beyond what we've done with the tool. Okay, so think of HANA as really the engine, as the predictive data store, but also the persistence layer for what we're doing in terms of when we predict and store content back to the device where it didn't exist yet, into the same schema, into a new schema, and make that available to the masses through the BI clients, through the BI suite, to other systems that need to realize it, right? So, and then think of predictive analysis, the tool that you're going to see today, is the modeler for doing that. Okay, that's how those two pieces run together. Okay, next one, please, Amanda. This next slide just gets into that a little bit more. It talks about the PAL. We'll leave this in here. When you do that, of course, that means that we're persisting the results back into HANA. You can actually persist results back in anything. So if you plan to connect Oracle up to Predictive Analysis, you can persist the results back to the Oracle database. And if your BI clients use that as your authoritative source for data, for analytic data, you can do it from there as well. It's a very quick implementation. Again, the integration is provided out of the box. Supports a lot of different types of algorithms. I know when you see the demo, Hillary will show you that. Very, very optimized for high performance, which is one of the really neat things that we have here. And then the next slide, please. And that just gets into leveraging HANA's predictive capabilities. There's a diagram here that really talks about where things are installed, where they reside, really what's going on when we do connect to HANA from Predictive Analysis. Again, Predictive Analysis is a workstation tool. It's certified with Windows 7 today, and the release right around the Sapphire timeframe will have Windows 8 support. And we're looking at other platforms as well, such as server platforms. In a subsequent release, we'll actually have a server daemon that will run on a location, so you can do multi-distributor development, scheduling of analyses, and things like that without having to go to the workstation and push a button. So all that really neat stuff is coming as well. We're trying to automate as much of this as we can, and create once, run many is the model that we're after here, and you can see that in the roadmap. Again, Predictive Analysis as a tool does not necessarily require HANA. It doesn't require the Business Objects BI suite either. So because of that, it's necessary to include pre-built algorithms and include an integration to R inside of Predictive Analysis itself that runs on your workstation. So you have the ability to do all this stuff, and that means that you can pull data from a relational database, from Excel, from CSV, from a BI3 or a BI4 universe. So we have all of those integrations already out of the box. That also means that we can connect to HANA and through this PAL I talked about earlier, do the exact same thing, only when we connect to HANA online, we're actually doing it in memory and we're doing it in database. So we're actually pushing all that logic and keeping the data in the place that it should be kept in. And then lastly, of course, again, closing the loop. We don't want to stop there. We don't want to just bring all our data sources in and create analytics and things like that, but we actually want to ensure that the results are persisted and they're produced and published out to the community. So the people that need to see it, executives within their scorecards, perhaps analysts inside of their version of predictive analysis or visual intelligence, end users in Explorer. We have a pre-built integration also to publish content right to Explorer, Explorer on a mobile device, and also Streamwork. Okay, and I think this could be my last slide. Lastly, you know, the great value proposition here, again, is that, in my opinion, is closing the loop on the analytics and ensuring that we have this ability to publish the results out to people in a very meaningful manner. And that is the way that they're expecting to see it. And for users who are already using BI and using Explorer, Explorer Mobile, maybe some of your customers or you as a customer are running, are using Streamwork to collaborate with colleagues. And we can publish the content directly to that. So two ways of publishing content out and getting it to the people who really need to see it. Directly to Explorer, Explorer Mobile, or Streamwork. And secondly, directly persisting the results and writing back to HANA. And then when we do that, everything within the BI suite that's connected to HANA can realize that and make use of that content. So if you want to do things in Crystal Reports and Webby, in dashboards, right? You can do that all from that capability. Okay, so again, down at the bottom, very agnostic in terms of the data source. We're not expecting any specific data source for this to work. We're not expecting one data source for this to work. You can have multiple. You can have it coming from anywhere. You bring it into the tool. You model your predictive models very intuitively without blowing anything up. You can only do good here, not bad. You get the data sets and the visualizations out to the user community by publishing it out. If you publish it with the same report that they're used to seeing with BI, For example, you could have actuals and a budget forecast in the same report, all coming from predictive analysis now.
Mike, I moved on to the use case, but we need to get to the demos. I don't know if you can just go through this last slide and we'll go to the demo just quickly.
Yeah, I'm sorry. Yeah, absolutely. Okay, so we've identified a lot of use cases. In fact, we have roughly about 126 use cases that we've identified that we're doing some work in. The ones on the screen right now are the most common. So identifying larger basket sizes. Most people are familiar with Amazon, right? You go to Amazon, you put something in your basket, it starts recommending everything else. We used to think it's annoying, but everybody copies it now who's in retail and has products online. So that type of thing. We're doing that with a lot of different companies right now who are in the retail space. In healthcare, predicting the likelihood of disease and utilities, load demand modeling and forecasting. Over in retail, markdown and price optimization up to the top. More in like public sector and in some form banking, fraud, waste, and abuse discovery. Looking for fraudulent patterns. Again, more in the retail and CPG areas. Cross and upselling, customer lifetime value, buyer classification. Customer churn is hugely popular. Everybody has this problem of customers leaving and going to a competitor. Telco is really infamous for that. We're doing a lot of work in that area. And then lastly, more in the manufacturing space, reduction in defective goods. So I'll quickly go to the next one. And these are predictive use cases for more of the line of business areas. So not just for industry. Industry are the most popular because everybody in industry has an idea what they want to do. They just aren't quite sure how to do it yet, and we can help with that. But for line of business, there's ones as well. So predicting market trends and customer needs, market price volatility, simply changes in demand or supply chain, deviations in quality issues, offers and service levels, future sales, right? Everybody wants to do that, or the forecasting of sales, what customers are saying about you, predicting cash flows, collections, risk, short-term borrowing, right? There's a lot of different use cases. Amanda, I'll just go to the customer success real quick. We have had success with this product. We've got customers who are realizing real benefits mostly in real time. You can see Cisco here is doing cluster analysis, which is really just partitioning and looking at sales by customer in certain geographical areas or by other attributes, and they're able to run that across millions and millions of transactions in about 2 seconds. So this is very fast, very efficient stuff. CR Food in the restaurant food service business, 80% faster budget creation cycle and extended real-time forecasting capabilities. MKI, which is in healthcare, 216 times faster by reducing genome analysis. Those are usually very big data optimized systems. And then BigPoint, who is in the gaming area, a 10 to 30% increase in revenue per year is what's expected. So there's more of these. Just wanted to share some of them with you. And with that, I will be quiet and I will hand it over to Hillary.
Thanks so much, Mike.
Hillary, I'm going to go ahead and make you presenter. You guys hang with us. We might run just a tad long. We'll see. Just hang with us. Hopefully you're getting a lot of value out of this, and we'll let Hillary run through the demo.
Thanks again. Hi, everyone. My name is Hillary Bliss, and I'm the Analytics Practice Lead here at Decision First Technologies. We're an SMB partner that's been working with predictive analysis on HANA for some time. My personal experience is working with various advanced analytics teams, particularly in the retail and consumer services spaces, developing models to predict customer behavior and optimize marketing and product offerings. I've worked with many other statistical tools, and I'm really excited to be working with predictive analysis now. I want to take you through one possible scenario for using predictive analysis to help solve a business problem that we can all relate to. Just to summarize the scenario for today, we work for a financial services company with a new loan product to promote. We have a database of 1.2 million potential prospects, but only a portion of all of these prospects can qualify for our product. In this case, just under 37% of our experience data set. This qualification and sales process costs us an average of $15 per contacted customer. So we'd like to develop some sort of rules to help our sales force only contact customers that are most likely to be eligible for this product. Once we've established that a prospect is eligible, they have an estimated customer value of $45 to our organization. I'm going to go ahead and open up Predictive Analysis so we can start our work. I've already loaded our experience data set into HANA and created an analytic view of the data, predefining our attributes and measures. This could be existing infrastructure that we use in dashboards or for business intelligence reports, and we can access it directly using predictive analysis. Since our data is located on HANA, all of the analysis will be pushed down and run on HANA. Some of the algorithms we're running are predictive algorithms in the R statistical language, which is called from HANA. However, the same analysis could be done with data from any other database or flat file, as Mike said, using predictive analysis and the local R installation on my laptop. After I've selected our analytic view, I can preview and select the columns that I want to include. This particular data set has a key field, prospect ID, the response field, eligible, and several demographic descriptors of each prospect, such as age, job type, employer type, and education information. I'll click OK to bring all of this data into my predictive analysis document. Once the document's created, I can go ahead and start performing data discovery immediately. Just by dragging and dropping attributes into the x-axis, I can immediately view the distribution of our prospects across our demographic characteristics. This helps us inspect the data for modeling and make sure that our distributions look right. I'm also going to want to look at the relationship between our response variable, eligible, and each of our potential predictors. So I've added our response variable to the legend color and created a stacked bar chart to see if we can observe any immediate insights into what might be predictive of eligibility. Here in the stacked bar chart, we can see customers in blue are not eligible for our product, while customers in green are eligible for our product. So as we flip through our possible variables, gender, job type, and age, we can see some trends. I don't think the eligibility differs very much by gender, but it does appear that job type and employer type could be indicative of eligibility. When we put age across the x-axis, we can see a definite trend that customers in the 20 to 40 age range are much more likely to be eligible, with customers at the extremes much less likely. I can also save these visualizations to share with coworkers with interesting insights, either via email or by sharing this predictive analysis document, which they can open if they have either visual intelligence or predictive analysis. At this point, I think I have some definite insights. It looks like the eligibility is most likely related to job type, age, and employer type. Once we've visualized this data, we can proceed to the Prediction tab. The first thing we might want to do is perform some clustering to better understand our customers. The clustering algorithm will create segments of customers most like each other based on numeric data fields. We're creating a predictive workflow here. I already have my data source, the HANA Analytics view, so I dragged in the HANA RK-means clustering algorithm, and I'll click to configure with my available numeric elements, age, education years, and hours per week. I'll also limit it to just 3 clusters since we only have 3 predictors. We can also write our cluster number back to HANA by pulling in the HANA Writer module and setting the output schema and table name. After we're finished, I'll be able to pull that data back into predictive analysis for visualization and further modeling. I'll go ahead and click the green arrow to run the analysis, and pretty quickly we'll be getting an alert that the results are available. Here on the results pane, we can see the same data set that we had before, but the new column, cluster number, has been added to the end. The cluster numbers 1, 2, and 3 are arbitrarily named, but here on the Charts tab, we can see some more descriptive information about each of those clusters. We can see the histogram here in the upper left showing the distribution of our data within the clusters. We have 2 pretty equally sized larger clusters and 1 slightly smaller cluster, but the good news is that all 3 clusters are pretty evenly populated. In the upper right, we have a chart showing the cluster density and distance between the 3 clusters. The depth of color shows how homogeneous the observations in each cluster are. Here, clusters 1 and 2 are relatively homogeneous in the darker blue, and cluster 3 in the lighter blue is less homogeneous. Cluster 3 is more like both 1 and 2, but 1 and 2 are very different from each other. In the bottom left here, we have a histogram showing each of our cluster variables for one cluster compared to the total population. Here we can see that cluster 1 in green is primarily the younger age group, compared to blue, which is all clusters. If I move the slider here to show cluster 3, we'll see that cluster 3 is primarily made up of customers in the middle of the age range. Here in the bottom right, we have a radar chart showing all 3 axes of the segmentation, which gives us an idea of how different our clusters are within each of our clustering variables. Age here on the vertical axis shows the most differentiation between the clusters, since you can see the vertices of the polygons are far apart, whereas years of education here on the right axis shows the least differentiation because the axes are all right on top of each other. Now that we've looked at some demographic characteristics of our clusters, let's see whether they'll help us determine which prospects to contact. Since we wrote the cluster number back to HANA, I can open a new document that I have ready to go based on that data set so we can start visualizing cluster eligibility. We're going to go ahead and look at the same baseline eligibility that we established before, and we'll see that 37% from our slide. When we pull in our newly assigned cluster variable, it's clear that the eligibility percentage is quite different between our clusters, with clusters 1 and 3 at 40% or higher, and cluster 2 just 20% eligible. At this point, we can look at the possibility of using cluster number in our marketing criteria. Here, I've summarized those cluster eligibility levels to project the cost per eligible prospect for each cluster. If our marketing strategy is to only contact clusters 1 and 3, we'll reduce our marketing cost per eligible prospect from $41 to just under $36, a savings of almost 13% over our current Contact Everyone strategy. This initial result is great, but perhaps we can develop even better marketing rules by creating a model specifically intended to predict which customers are eligible. We're going to go back to predictive analysis, and I'm going to fit a decision tree on our modeling data. A decision tree is a rules-based prediction tool for categorical outputs. This is very appropriate for our categorical output, eligible or not eligible. Here in our workflow, I've gone ahead and prepped the RCNR tree module with the 3 variables that we determined during discovery were most related to eligibility: age, job function, and employer type. I've also entered the response variable eligible. I'm also telling predictive analysis to go ahead and save our model algorithm for later. I'm calling it tree model, and I can go ahead and run this by clicking the green button. One reason that I selected a decision tree model is that they're pretty easy to understand and implement. So if our decision tree predicts eligibility well, this type of a model will be easy to transfer to a database and explain to the sales staff. Now that the decision tree has been run, we can look at the results of our model. Here in the decision tree results, we have the same data set that we provided, including the cluster number from our previous model. But predictive analysis has now added the predicted values field. This is the decision tree model predicted eligibility status. By clicking on the charts, we can see a visualization of the tree rules that were fitted to our data. This is telling us here at the top that we should exclude anybody with service job type. But for those with professional and skilled trade, we'll proceed down to the next level and see what kind of employers they're working for, further excluding any that are self-employed or in the other category. For those in the government and private service sectors, we can continue down and look at some other breakouts by age until we've defined all the possible accept or don't accept scenarios. Let's visualize the tree results and see the impact of using this model in our marketing scheme. I've gone over to the Results Visualization tab and pulled in our measure and our predicted value. This is the predicted eligibility based on our tree. I've created this pie chart similar to our original baseline that shows our predicted eligibility based on the tree is about 41%, not too far off from the 37% in our experience data set. I'm going to go ahead and filter for just those records that we've predicted to be eligible. And then I'll pull in the actual eligibility from our experience data set. So we can see that our predicted eligible customers are 71% eligible, which is much better than the 37% eligibility on the full population or the 40 to 44% eligibility on our selected clusters. One more quick thing before we go back to the slides. Since I saved our model, I now have it available on the Saved Models tab, and I can drag and drop it into my analysis to score any future data sets, should we decide to use this model. Or I can export it to the universal PMML modeling format and import it into any database or application that can accept PMML models. This will allow us to call the model like a function and score any new records we add on demand within our database or application. Returning now to our marketing proposal, based on the decision tree we just built, I'm looking at a confusion matrix which shows the actual eligibility in a cross-tab view with the predicted eligibility from our tree. Those groups that were accurately predicted in our model are in the green cells, with the unshaded cells representing false positives, with 12% in the upper right, and false negatives, with 7% in the lower left. Luckily, we can see here that the model is quite accurate. Adding the two green cells together, over 80% of the data has been predicted accurately. If we decide to only contact the portion of customers that are predicted eligible by the decision tree model, we'll have reduced our cost per eligible prospect from $41 to just over $21, effectively cutting our marketing costs almost in half. Summarizing these two marketing models we developed, we can see the full value proposition here, with the current contact everyone strategy in the first column, and our two model-driven options, option 1 with the clustering rules and option 2 with the decision tree. Rather than contacting our full 1.2 million record database, the model rules suggest that we contact just a small portion of the database, significantly reducing our marketing costs, but only cutting the total value of eligible prospects by a small amount. The decision tree model is the best option here. The reduced marketing cost of $21 per eligible prospect yields a savings of nearly $11 million in marketing costs. As it says at the bottom of the slide, using the decision tree model, we can do 60% less work than in the current scenario, while yielding a 371% higher net value to the organization, which is pretty impressive. Once we've received approval from the management team to implement these new marketing rules, we can either use our saved model within Predictive Analysis to score the entire 1.2 million record data set and write this back to our CRM or lead database, or we can export these rules to a dashboard widget, which we can make available to our frontline sales folks. Let me show you an example. Here, I've simply exported the tree model rules and programmed them into a business objects dashboard. With this widget, a sales rep can have this on their desktop and go ahead and enter any new information for a prospect that comes in that they might want to contact. And they'll get an immediate on-demand answer from the corporate marketing standard rules for whether they should expend their effort on this prospect or not. I hope this simple example made sense. While this example was for the financial services industry, it could easily be any retail, consumer services, charitable, or marketing firm. I'm also going to include this references slide for anyone who has continued information on predictive analysis to reference. I'm going to go ahead and hand it back to Amanda for any questions. Thanks so much for your time. Amanda?
Great. Thank you so much, Hillary. The only one thing I wanted to mention before we move to Q&A is if you're going to Sapphire, please stop by our booth at 2322, and we'd love to take you through some more predictive analytics or HANA or business objects. We'd love to just get to know you a bit and share with you what we do. With that, let's go to some questions. Mike, are you there?
I am.
Okay, Mike and Hillary. So whichever one of you wants to take this. Can we overlay multiple demographics, for example, age and gender?
Yeah, Hillary, I think you showed that, right? Being able to analyze multiple attributes.
Sure. Do you want me to?
No, I just want to just make answering the question. Yes, the answer is yes, that you can overlay multiple demographics, correct?
Definitely, definitely. And you can do that from a visualization standpoint. Before you do the prediction, you can also do that in a predictive model. This multivariate, multi-attribute capability is pretty native to predictive. Not many people want to run predictive analytics against a single attribute. So absolutely.
Okay. How is the eligibility variable created?
The eligibility variable would be from our experience data set, so we had to have some sort of past indicator of whether records would be eligible or not. So this is, maybe the last call campaign that we did, and then that's how we used to predict our future eligibility.
Okay. Can the cluster definition be controlled so instead of random cluster numbers, specific clusters are named based on requirements?
Once you have the model built, you could rename the clusters to be called whatever you want. I mean, the tool will just call them, 1, 2, 3, 4, 5, however many you have. But then within your organization, when you go to implement that, you could certainly assign business names, these are our Tier 1 customers, Tier 2, whatever.
Okay. Mike, I think this was from earlier in the presentation. Why is human capital not on the radar screen? Slide 5. I don't know if you...
Not enough real estate on the screen. That's simply why.
Yeah.
We do have workforce modeling, recruiting, forecasting, those kind of things that have continued to come up. So absolutely, we are seeing interest in that area. Just didn't have enough room on the screen.
Great. Okay. And where is the statistical engine in your model?
In the demo we did today, both of those algorithms were running on R through HANA.
Okay. And does the PAL is it included in the HANA database?
It is.
Okay.
PAL is included. That allows you to run functions within the and do in-database predictive analytics inside of HANA. It's included.
Okay. Great. I think that may be all our questions, unless somebody wants to chat a question to us. I think we might have gotten through all of them. Okay. Great. Don't see anything coming across. Well, thank you, Mike and Hillary. That was a great presentation and demonstration, and thanks for the great questions we had. If you have any questions after the fact, feel free to contact any of us on the last slide that should be up, and we really hope you'll participate in one of our upcoming webinars again. We are planning to do one on enterprise information management, another expert series. If you've attended some of our past DFT webinars, we do like 4 and 5-part series on certain topics. It looks like in the summer we're going to do one on enterprise information management, so we'll get more information to you on that. Thanks, everyone, and I really appreciate your attendance.